Hello, welcome to Notes. In this video, I'll be testing my UART API, and in this project, I'll be just transmitting this buffer UART testing from my STM32 board to Arduino board. This Arduino board is configured in standard mode where the data length is 8 bits and there is no parity bit and the number of stop bits is 1. And by default in a STM32 board, this board has a hardware for USART, that is Universal Synchronous Asynchronous Receiver Transmitter, but by default UART is configured, that is Universal Asynchronous Receiver Transmitter. So in this project we will not be using any clock pin and will also not be using any hardware for flow control pins like request to send, clear to send pins also. So basically we'll be using only two pins, that is TX and RX, and these two are the pins. So let's begin. So now let's get into the demo. In this project, whenever I press this button on STM32 board, I'll be sending the string byte by byte to my Arduino board. So let's start the demo. So this is my serial monitor and you can see there is nothing printed here. I have initialized my Arduino board, so I'll increase the brightness. So whenever I press this button, I should get UART testing. I got it. I'll be pressing it again. So I have pressed it 4 times and I have received it 4 times. Let's analyze this using my logic analyzer also. And here is my logic analyzer connected to these two pins. Here is what I have captured from my logic analyzer over here by keeping it to or giving it to both TX and RX, and this is the timing diagram which my logic analyzer have captured, and here the D1 is TX and D2 is RX. For now, ignore the D2 line and mainly focus on D1 line, and this is our TX. The interesting things to know here is the format. In UART, we don't have repeated start like we have in I2C. So, after every 8 bits or the way which you have configured, like from 5 bits to 9 bits, the size of data frame can be in UART. So, if you have configured it for 8 bits like I have done, you must generate a stop bit after every 8 bits of data. If you fail to generate the stop bit, which is over here, the error like frame error will occur definitely. So after every 8 bits or the data length which you have configured, you must generate a stop bit, and initially the TX line will be high. When you pull it low, it signifies it is the start bit, and here is the start bit, and here we have pulled the line to low, and the next 8 bits from here will be the data. So the first data will be U. Here we are sending it byte by byte because the data length can be maximum of 9 bits and minimum of 5 bits in UART protocol. And again after the 8 bits we must pull the line to high. So it signifies our start bit, and here it is indicated by T. Again to start the UART protocol, again we must pull this line to low, and here it is the start bit. Again we must send our next data, that is A. Again we must pull it high to signify the stop bit, and here it is again start bit. Similarly, like this we must transmit all our data. You can see here UART testing. This was the waveform which is kept by my logic analyzer. This is my source file where I have written this code, and first I am initializing my USART 1, but I have written this USART 2, but I am using USART 1 itself, you can see here, and I am setting the baud rate here, and I am not using any hardware flow control, and I am enabling only TX block, and the stop bits is number of stop bits is 1, and next the word length is 8 bits, and I haven't used any parity bits. Coming to this, I have used pin 10 and pin 9 as my TX and RX pins. Here is my GPIO button initialization, and the next thing will be just transmitting. I have initialized everything here. I have just called the functions which I have written above, and just whenever I press the button, I just transmit the string which is mentioned here. And I can show you my source file, driver source code. This is the driver source code. I will be putting it in my GitHub repo. You can check it in my comment section. This is my header file of USART driver. Important things to note in my STM board is, as I am using a nuclear board, you can't use the TX and RX pin of UART2, that is USART2, and the pins are these two, which is written as D1 and D0. You can't use them because it is directly connected to ST-Link, and the board doesn't allow you to use that pins, and even if you configure that, you will definitely not get outputs. So try using other USART blocks like USART 1. You have up to 5 blocks. So try using other than USART 2, especially these two pins. This was the thing which I noticed where I went wrong, and and one thing I just forgot to show you. See, STM32 supports both USART, and that is synchronous and asynchronous receiver transmitter thing. So you can see here we have a CTS. These two are hardware flow control things, that is request to send and clear to send pins, and this is transmission, the TX pin, and this is receiving pin RX, and here the another thing is clock pin. So you can use this board as both synchronous and asynchronous receiver transmitter. That was all about this video. Thank you for watching, and if you do have any doubts regarding this, please do comment it down. Thanks a lot.